Now we will discuss about some examples. First one, a 50 kVA delta Y distribution transformer has a resistance of 1% and reactance of 7% per unit. So A part, what is the transformer's phase impedance referred to the high voltage side? So what is the transformer phase impedance referred to the high voltage side? So first we know in this transformer has a per unit impedance is 1% and 7%. Okay, so per unit impedance we know resistance is 1%, so 0.01. This is 1%, so 0.01, and reactance 7%, so 0.07. So this is the per unit impedance. So first question is high voltage side. High voltage side refer to the high voltage side phase impedance. So to calculate the high voltage side, refer to the high voltage side phase impedance, we have to find out the base impedance. So how can we calculate the base impedance? So this is the in this question they are asking refer to the high voltage side. We know this is delta Y distribution transformer. Here the high voltage side is delta. High voltage side is delta. Yeah. So this is the delta connection. So therefore we know base impedance is equal to phase voltage square should be divided by apparent power. But in this question we are using 3-phase transformer. Okay, so the total apparent power is S, then the single phase power is S by 3. Okay, so base impedance is equal to 3V square divided by S. Okay, then we can use the phase voltage. So in this transformer high voltage side is delta connection. So in the high voltage side is delta connection, so line to line voltage and phase voltage both are same. Therefore the phase voltage is equal to 13,800 square and should be divided by apparent power. What is apparent power? 50 kVA. So 50 into 10 to the power 3. So if you divided these things, you will get 11,426 ohm. Okay. So this is the base impedance. From this base impedance refer to the high voltage side. This refer to the high voltage side base impedance. From this base impedance we can calculate the actual impedance refer to the high voltage side. So we know actual voltage refer to the high voltage side is equal to per unit multiplied by base impedance. Per unit impedance multiplied by base impedance. So per unit 0.01 plus 0.07 multiplied by 11,426. From here we can say 104.26 plus J800. So the actual impedance referred to the high voltage side is 114.26 plus J800 ohm. Okay, so this is the impedance referred to the high voltage side. Okay, now we will move to second part. Okay, calculate this transformer's voltage regulation at full load and 0.8 power factor lagging using calculated high side impedance. So in this question they are asking voltage regulation referred with high voltage side equivalent circuit. Yeah, high voltage side equivalent circuit. So first we will consider the high voltage side equivalent circuit of this transformer. High voltage side equivalent circuit of this transformer. So we neglect the excitation branch. So this is the impedance part, and this is output, and this is input. So when we consider the high voltage side equivalent circuit, so this is Vp, and this Vs should be A into Vs. We referred with high voltage side, therefore this is Vp and this is A into Vs. At the same time, impedance value we already calculated those things, 114.26 and J800. Okay. First, in this question, we are going to calculate the secondary voltage A into Vs. We know in the delta Y distribution transformer, secondary voltage is 208 voltage, and this is the Y connection. So this is the 208 voltage should be a line to line voltage. Therefore, first we have to calculate the phase voltage in the secondary side. So phase voltage in the secondary side should be equal to line to line voltage divided by root of 3. So this is the secondary side phase voltage, line to line voltage divided by root of 3. So if you divide it by root of 3, you will get 120 voltage. So this is the secondary phase voltage. From this voltage, we can calculate the secondary voltage refer with high voltage side, A into Vs. So what is A into Vs? A into Vs, if you calculate A into Vs, this would be equal to 13,800 voltage. 13,800 voltage. You can calculate using a delta Y distribution transformer in high voltage and low voltage side voltage. From that you can calculate the turn ratio of this transformer. Then we can calculate A into Vs. So A into Vs would be equal to 13,800 voltage. Okay. Now we will calculate the current. Of this transformer. Okay. So in this transformer, this is the phase current. So this phase current, we are going to calculate the voltage regulation at full load condition. Yeah, we are going to calculate voltage regulation at full load condition. Therefore, this phase current should be a rated current. So in this transformer, the rated power 50 kVA and rated voltage in high voltage side 13,800. So therefore, phase current is equal to power, apparent power for one phase, S by 3, one phase should be divided by phase voltage. So power is divided by phase voltage, then we can calculate the phase current. Okay. Apparent power is 50 kVA, 3 into phase voltage 13,800. So what is phase current of this transformer? 1.208 ampere. Okay, so this is the phase current of this transformer. Okay, so we have calculated the impedance, we have calculated the phase current, and we have calculated the output voltage. From these things, we can calculate the input voltage or primary voltage. Okay. So input voltage Vp is equal to Vp is equal to A into Vs, output voltage A into Vs plus that's a voltage drop. Yeah. So the voltage drop I phase current I into R plus Jx. Okay. So what is A into Vs? We have already calculated that 13,800 plus phase current. We know in this transformer, we are going to calculate the voltage regulation at 0.8 power factor lagging. So we have to calculate the power factor angle. Here the phase current is equal to 1.208 and power factor angle. What is power factor angle? We know cos theta is equal to 0.8. Cos theta is equal to 0.8. Therefore, theta is equal to cos inverse 0.8. Then we can calculate the lagging power factor angle minus 36.87. Okay. So this is the power factor angle. So 1.208 minus 36.87 into multiply by R. What is R? 114.26 plus J 800. So if you calculate those things, you will get the input voltage. So what is input voltage? If you use this equation, we can calculate the input voltage. And what is input voltage? $14,506 2.73 angle. Okay. So this is the input voltage. This is the Vp. So we have calculated the primary side input voltage, and we already calculated the output voltage A into Vs. From these two things, we can calculate the voltage regulation. Okay, I got the idea about this. So A into Vs calculated. Phase current, here we have to consider the power factor angle. So we can calculate the power factor angle using a power factor. Okay. So then after we have calculated the input voltage. Okay. Now we will calculate the voltage regulation. So voltage regulation is equal to Vp from this equivalent circuit, Vp minus A into Vs divided by A into Vs. Okay. Refer with output voltage. Okay. So Vp 14,506 V pi is 13,800 divided by 13,800 should be multiplied by 100. So it expressed with percentage. So what is the percentage? If you calculate using the calculator, 5.1%. So voltage regulation is 5.1%. Okay. Okay. So now we will move to third part of this question. Okay. Third part. We are going to calculate the voltage regulation under the same condition using per unit system. We are going to calculate the voltage regulation using the per unit system. So we know when we consider the per unit system of this transformer, per unit system, the resistance is 0.01, impedance reactance is 0.07. Yeah, resistance 1% and reactance 7%. And this is the output voltage and this is input voltage. So we are going to consider output voltage. Output voltage is 1 per unit and current also 1 per unit. Okay, 1 per unit current. So we know VA into if you consider per unit part, this is per unit voltage and this is per unit current. So according to this equivalent circuit, we can say output voltage, per unit output voltage, per unit input voltage, per unit input voltage is equal to per unit output voltage, per unit output voltage plus per unit current, per unit current multiply by per unit impedance, multiply by per unit impedance. Okay, so what is output voltage? Per unit output voltage is 1. Okay, 1 0. So we can refer this is 1 0 with phase angle is 0, and input current, the transformer current, we know that we refer the current is 1 per unit, but the phase angle, there is a phase difference between voltage and current minus 36.87. Okay, so this is the per unit current multiplied by impedance, per unit impedance, so 0.01 plus 0.07. So if you calculate the input voltage, per unit input voltage, so it would be 1.051 2.73. Okay, 2.73. So this is the input per unit voltage. From this input per unit voltage and output per unit voltage, we can calculate the voltage regulation. We can calculate voltage regulation. Okay. So when you focus on the voltage regulation is equal to per unit output voltage, input voltage, per unit output voltage, and per unit output voltage. Okay, so this is 1.051 2.73. This is not important, so we have to use a magnitude value only. So here 1 per unit divided by 1 and multiply by 100. So what would be the value for voltage regulation? This would be 5.1%. So the voltage regulation of this transformer using a per unit system is equal to 5.1%. So we can calculate the voltage regulation using per unit or using a actual value. Okay. Normally, when we use a transformer, we are expecting for a good voltage regulation transformer. We are expecting a good voltage regulation transformer. But in some exception case, we have to prefer for poor voltage regulation transformer. That means some case we have some benefits of poor voltage regulation transformer. For example, if you consider the discharge lamp, if you consider discharge lamp, in this discharge lamp we are using step-up transformer. In the discharge lamp we are using step-up transformer. So why we are using step-up transformer? In this discharge lamp we have an anode and cathode. So from this anode to cathode we have to create the current, we have to generate the current. But to generate the current we have to ionize the gases. To ionize this gas we are using high voltage. So if you ionize this gas, then there will be a current flowing from anode to cathode. There is a current between anode and cathode. Okay. So if you ionize this gas, then there will be a current flowing through these two terminals. To ionize this gas, we are using high voltage. Therefore, for start the current, to initiate the current, we need high voltage. But after initiate the current, then current flowing through these terminals, then we do not need any high voltage. To start the current, we need high voltage. Then after we do not need any high voltage. So at this time we have to use poor voltage regulation transformer. Why? When we connect this transformer, step up transformer between these two, if you connect the transformer between these two terminal, it produces the high voltage between these two. So initial condition. Then the current flowing through these two terminal, at that time the step up transformer voltage should be dropped because it is the poor voltage regulation transformer. Therefore we can say at initial condition it give a high voltage. After current flowing through these two terminal, then because of this load, then there will be a voltage drop, high voltage drop. Okay, because it is a poor voltage regulation. So there is a high voltage drop, then the current high voltage drop, then we can use a discharge lamp in a very efficient way. Okay, we can use the discharge lamp in very efficient way. So this is the benefit for poor voltage regulation transformer. At the same time, same example for we can apply in arc welding circuit. For arc welding also we need a high voltage, but at that time we do not use any step up transformer. We are using arc welding with using a step down transformer, normal transformer. So in the arc welding also we need a poor voltage regulation transformer, because to initiate the current we need a high voltage. Then after we do not need any high voltage. Therefore in the arc welding machine also using poor voltage regulation transformer. So these are the case we are using poor voltage regulation. This is the benefit, or this is the advantage of this poor voltage regulation transformer. Okay, I hope you can get a basic idea. You can refer further things about discharge lamp and arc welding. Okay, thank you very much for your cooperation.